Good morning, children. It's Mr. E. Today we're going to learn how to solve systems of equations by using a method called elimination. We're going to do this first. Starts on page 7 in your packet. I know it's not in order, but that's okay. This is the method that you're going to use the most. So we're going to do this first. So you'll use this again in geometry quite a bit. In fact, that's probably the only way that you'll use it. The only method you'll use, as well as Algebra 2 and whatever else you go to after that. So let's get started. Here it is. Solve systems of equations by elimination. Okay. Alrighty. So we start by putting both of our equations in standard form. We're going to use standard form, which is ax plus by equals c. There's a reason that we do this, and that reason is as follows. This way we have 3 columns. Here, just go and put lines. Here I have the x terms column. Here I have the y terms column. And here I have the constant column. Good look. Yeah. Constant. There. So I've got 3 columns, and this is very important because we're going to use that to keep track of our equations as we solve them. So there we go. So let's see. What we do then is we eliminate. That's where this goes in. Eliminate. There we go. Looks like eliminate. There we go. We eliminate a variable by multiplying all of the terms in one of the equations. If needed, if we need to, then we do. Sometimes we don't need to, but sometimes we do. So solve for the variable that remains by, so we're going to solve for the variable that remains by combining like terms. That's step 3. And then the last step we're going to do is to plug in the value to solve for the other variable. Okay, all this will become clear here in just a second. So here's our first system. This one is set up real easy. It's kind of in the middle of the process, really, because what we're looking for is this. And I want you to write this up top. Green, because that way you remember it better. The key to setting up, let's see, to set up. Here's a tip for setting up your equations. You want to have same coefficient, but different signs. Remember this. This is what we're looking for here. The same coefficient, but different signs. Just like right here in our x columns, here's the x terms. There we go. There's the x terms. Here's the y terms. And there's the constants. Here's the x's, here's the y's, and here's the constants. Here we have the same coefficient, 4, but different signs. This is a plus and this is a minus. So this is set up for us real easy and it's ready to go. So all I need to do is, let's see, that's both equations are in standard form. Check. We're going to eliminate a variable by multiplying, but we don't have to this time. We're starting off kind of in the middle of the process. So it's already set up for us, so we don't need to do that right now. Solve for the variable that remains by combining like terms. And what they mean by remains is this. 4 minus 4 is 0. Or 4x, rather. 4x minus 4x. We'll just zero that out. So that's 0. So we have eliminated the x's. And all that remains is the y right here. 8 plus 2, that's 10 y's. Get rid of the 0. I don't need anything over there. So 10 y's equal, and I'm going to combine this over there. 20 minus 30 is a minus 10. So now all I have left is to solve for y. It's being multiplied by 10 right now, so I'm going to unmultiply it. Divided by 10, that goes to 1, and this is negative 1. So y equals negative 1. So now I have y. Y is negative 1. Y equals negative 1. There's the first bit. And now that's step 3 done. Then I just plug in the value to solve for the other variable. Well, now that y is 1, I can choose either one of these equations and plug in minus 1 for y. So I'm going to use the top one for x plus 8. Instead of y, I'm using minus 1. Look at it right there. Equals 20. That's the top one here. I'm using the top one again. So I just multiply this out. Now this is 4x plus 8 times a minus 1. Oh, that's a minus 8. So here's minus 8 equals 20. So now I can just solve for x. Oh, y is down here. Minus 1. I can just solve for x as soon as I make a little bit more room here. Let me just evolve this up here. Oh dear. I'm not going to have room now. It's okay. Whatever. Okay, so let's add 8. Oh, let's get a pen back. There we go. We're going to add 8 plus 8. That goes away. So now I have 4x equals 28. Go up here. 4x equals 28. So divide by 4. We get x equals 7. There we go. So x is 7 and y is minus 1. So the point where these two lines cross is at 7 minus 1. And if you were to graph that, then you'd see that, just like we showed on the first day of this unit. So now we can verify the solution. We can plug both of these, this x and the y. So this is 7, and this is minus 1. This is 7, and this is minus 1. We'll plug those in just to make sure. So 4 times 7 plus, that's 8, plus 8 times a minus 1 equals 20. Let's see if that's right. This is 28 plus a minus 8. Yeah, minus 8 equals 20. Yeah, 28 minus 8 is 20. There we go. That works. And this one over here, let's see. Minus 4 times a 7 plus 2 times a minus 1 equals minus 30. So multiplying that, that's a minus 28 plus, well, a minus 2. Minus a 2 equals minus 30. And that's right. We'll combine these two on the other side. Minus 30 equals minus 30. That is correct, sir. All right, there. We've done one. Let's do another one. Let's do another one. Let's use a different color. Let's orange. And solve this system of equations by elimination. Now, look, this one's set up for us again, so this is pretty easy. Just want to show you that here we have the same coefficient, but different signs. So that means I can zero this out. I've got a 0 pair right here, 0 pair. So that goes to 0, then I can just add the y's. So 5 and 4 are 9 y's equals a 1 minus a 10 is a negative 9. So divide by 9, and we've got y equals negative 1 again. How about that? So y equals negative 1, and I'm going to change colors just to differentiate between the two equations. So now I have minus 1 for y. I'm going to plug it back into this equation because it's the one that has positive and make it easy. So I've got 6x plus 4 times y, which is now negative 1. That equals a minus 10. So just multiply that right there. That gives me a minus 4. So 6x minus 4 equals minus 10. Add a 4 to both sides to get rid of that term. 6x equals minus 6. Divide by 6. And x equals negative 1. Wow. Same thing. How about that? So the solution is minus 1, minus 1. Let's verify. We're going to put a negative 1 in for both variables now. Write that right above there so you don't forget what you're doing. Oh, don't forget the 1. All right, minus 6 times a minus 1 plus 5 times a minus 1 equals 1. It's a lot of 1s. Let's multiply there. Minus 6 times a minus 1 is a positive 6. 5 times a minus 1 is a minus 5. That equals 1. Yep, 6 minus 5 is 1. Check. All right, over here we got 6 times a minus 1 plus 4 times a minus 1 equals a negative 10. Well, that just changes the signs on both of these, doesn't it? So minus 6 minus 6 minus 4 equals minus 10. Yep, minus 10 equals minus 10. Check. There. We've done a couple of these. Let's see. Let's do a more difficult one to show you exactly what I mean. There we go. Here's a couple. Let's look at these. Now, here we have different coefficients and the same signs. But let's look over here at y. We have the same coefficient and the same signs. So all we need to do to eliminate y, and it doesn't matter which one you eliminate first, eliminate whatever's easiest for you. Here, if I wanted to eliminate the x, I need to find something common between the two so I can zero it out. And that means I'd have to multiply the top by 8 and the bottom by 7. That way I would have, I'm not going to do the whole thing this way. I just want to show you. If I multiply that, that gives me 56x. And the bottom, well, I'd multiply by negative 7. 7 times 8 again is 5, 56. And then on the bottom, I'd have negative 56x. That way I could zero that out. But I'm not going to do that yet because we have the same coefficient but same signs. So I'm going to use smaller numbers and just multiply the bottom by a negative 1. That's going to change the signs on all of these, and that way I'll have a different sign here for that one. So I'm going to rewrite it down here. I'm going to start at the top. You can use orange. I'm going to rewrite it like this. Go over here so I can have some room. So I've got 7x plus 2y equals 24. The second one, I'm going to multiply. Now, look, I've got parentheses around the entire equation, even over the equal sign here. So that means I'm going to multiply everything. So all 3 terms, the x, the y, and the constant. Okay, so negative 1 times 8x, that just gives me a negative 8x. A negative, where's that one? Negative 1 times 2, that's a negative 2y. And see, now I've got the same coefficient and different signs. So there we go. And that equals a negative 1 times 30, that's minus 30. So now I can eliminate y. So I multiplied one of the equations. That just scales it up for us so we can eliminate one of the variables. So let's eliminate a variable. We are going to, I don't need to change. Let's see, we're going to just start here and combine the two. So 7 minus 8, that's a minus 1x. We'll just put minus 1x for now. Here, this zeroes out, so I've got no more y's. And that equals 24 minus 30, gives me minus 6. So I'll just scooch this over so it's easier to read, and I'll take that 1 away. So it's minus 6 equals minus x. So that means x equals 6 positive. Just change both sides there. So x equals 6. Now that I know what x is, I can plug it back into the orange equation. So I'm going to plug it in right here. Start over here. 7 times x, which is 6, plus 2y equals 24. Again, give yourself a little bit more room. 7 times 6, there we go, plus 2y equals 24. There we go. So let's multiply that. That is 42 plus 2y equals 24. Let's subtract 42 from both sides. That goes away. I've got 2y equals, let's see, 24 minus 42. I'm going to have to break out a calculator for that. It's too early in the morning for my brain to do mental math, and that is perfectly all right. Let me see. No, that's a 1. 24 minus 42 equals negative 18. Negative 18. Okay. Let's divide by that coefficient. So we have one single y. And that equals negative 9. So y is negative 9. So our solution is 6 comma negative 9. Let's plug it back in to verify. X is 6. And y is negative 9. All right, here we go. 7 times 6 plus 2 times a negative 9 equals 24. Well, that's 42. That is minus 18 plus 24. Isn't that what I just did on the calculator? Yeah. 24 equals 24. Shakarooski. Over here we have 8 times 6 plus 2 times minus 9 equals 30. This is 48. This is minus 18. And that is correct as well. There we go. All right, let's do one more. I have a feeling this one's going to need a little bit of work. Yes, it is. Look at this. Okay. We have 2 equations here. Let's see. These coefficients are different, 5 and 10, and the signs are the same. So that's not what we want. These coefficients are different, and the signs are different. So let's eliminate y. Let's eliminate the y's here, because the signs are different, so we won't have to worry about multiplying by a negative or anything like that. But we will need to multiply this top right here by, what do you think we'll need to multiply by? We need to get the same coefficient. Well, we've got 1y there, so we need to multiply by 7. We multiply the entire top by 7. So that gives us 35x. That gives us positive 7y. Oh, where are you going there? And that gives us 63. There's that. Okay, this equation right here, this stays the same. So I've got 10x minus 7y equals negative 18. Let's combine those. Let's see, 35 plus 10 is 45x. Plus 7 minus 7, there's my 0 pair. We knew that was going to happen. This equals 63 minus 18. Let me get my calculator again. 63 minus 18. 45. Oh, look at that. So 45x. I'll move this over here. 45x equals 45. Well, divide by 45. X equals 1. Let's write that down here. X is a big 1. Okay, now that we know what x is, we can go back to the blue equation. I'm going to plug it back into that one because everything's positive up there. So let's see right here. See, that's 30. Oh, no, you know what? You could do that, but I want to keep my numbers even smaller, so I'm going to go back to this equation. This one right here. Yeah, this one right here, the 5x plus y. Those have the smallest numbers. So I won't have to break out my calculator. So let's bring this down right here. 5 times x, which is 1, plus y equals 9. Well, 5 times 1 is just 5, so 5 plus y equals 9. So I'm just going to subtract 5 from both sides, and then I have y equals 4. There we go. Come back. There we go. So the solution is 1 comma 4. Let's verify. There's a 1 here and a 4 here. 1 here and a 4 here. So let's rewrite 5 times 1 plus 4. We don't need to do that. Equals 9. 5 times 1 is just 5. Yes, 5 plus 4 equals 9. Thank you. That checks out. 10 times 1 minus 7 times 4 equals negative 18. Let's see. That's just 10. That's a 28. That checks out too. All right. So here's the thing to remember for elimination, because you're going to use this quite a bit. So take the time to learn it and practice and make sure you understand it. If you don't understand it from me explaining it to you, then be sure to talk to your own teacher or talk to me again and I'll explain it differently. This is what you need to remember. To set it up, you want the same coefficient, different signs. Same coefficient, different signs. Okay, so you put both equations in standard form. Then you eliminate one of the variables by multiplying all the terms, just like we did on the other side. Multiply by a negative if you need to. Multiply by a number. Remember, you're multiplying all the terms, even across the equal sign. Okay, you're multiplying the entire equation. Write that there, actually, entire equation. Okay, then you solve for the variable by combining the like terms. You combine both of those equations together, and you solve for whatever's left, and then you plug that in to solve for the other one. And that's all there is to it. So, that's it. So, yeah, okay. I will see you next time. Bye.